quickly on MaibornWolff. So we do custom software development, means we're consulting, building, and also operating the software solutions that we build for our customers. And we're about 1,000 employees, of which maybe half are working either on projects in product digitalization, so connected products, or on smart factory topics. And we do have quite a few LLM and AI agents projects in production already, in other sectors, but not yet in manufacturing. And just today we want to share with you what we learned so far on how we could use AI agents in manufacturing and how we could combine it with a unified namespace. All right. So this is John. John has a problem. John has to solve questions that can come up every day in manufacturing, has to solve them with the data stored in these servers in nice little silos in ERP system, MES systems, SCADA, or even on the operator terminal. And the problem is that it's really hard for him to get all the data from all these systems. So he has to talk to the system responsibility, try to get the data, try to get some export, then he puts everything into an Excel sheet, tries to combine the data. I mean, you all probably have seen this. And then he ends up with this huge Excel sheet that no one except him understands anymore. And this all takes, if just to answer the new question, takes days and weeks to come up with a solution. And even worse, sometime he even might need help of some data scientists or like external software development companies like ours. And then he might have to go through procurement, and then this can take even longer, since I don't know about your procurement departments, but this can take a few months. So all in all, this really drags on and makes it really difficult to solve new questions that come up, and to try to optimize things. And now, wouldn't it be great if you, instead of doing all that, if you could just ask the AI agent for that question and immediately get an answer? Or even better, the AI agent might even explain you what the problem is, maybe suggest a solution, and then maybe even execute the solution after you confirmed that's what you want to do. And Kirill is going to give you a short intro on how these AI agents work, and then I'm going to take over again and speak a bit about how you combine it with the Unified Namespace. Kirill.
Yes, thank you, Mark. And hello, everyone, from my side as well. So we're going to dive into some of the AI basics, and I hope you excuse it if you have heard it all, but I think from time to time it's helpful also for people to see where it actually comes from and where we are going. So back in the days, AI is actually nothing new. We didn't call it AI at this time. We called it machine learning a few years ago. But there were some differences compared to nowadays AI. So with classical machine learning, what we did, we had like really narrow tasks, really specific domains where we could have used machine learning. And what we did typically was like we had like really specialized and maybe small models, which we could apply for a specific domain. And they were really for some really specific task. What we needed to do is upfront was a lot of data uplifting. So we needed to have the data in the first place. We needed to have quality data. We needed to do data engineering and also the training. So it was a lot of upfront work to actually keep it running. And nowadays with AI or Gen AI or whatever you may call it, the paradigm has switched somewhat. So what we now do is, or what we can do is we really can address like open-ended tasks. So we do not necessarily need to focus on narrow domains. We really can act open-endedly. So an agent, for example, can do open-ended tasks planning. for this, we do not necessarily need this heavy data uplifting upfront because we are using foundation models, and foundation models are something that are already pre-trained, so we can just leverage it and go on. So, but still, what we should not forget is that we still need some data, because using a language model or foundation model right away doesn't provide meaningful or anything useful for most companies. So what we still need is this context, and we need to bring the context of our company, of our enterprise, into the language model. So this makes it really helpful, and this is what is meant by context engineering. So we need to bring the context into the language model. So just to give you also some sort of foundations on that. So where it all starts from is there is this large language model in the middle, which is just a giant neural network. And then there on the left side is this heavy data lifting and bringing all the different domains and different modalities, like for example, speech, images, 3D signals, all this stuff. Bringing the data up into place and training this model. And we, as a company or as a user, do not need this, do not need to do this anymore ourselves. So this is what OpenAI does. This is what Anthropic does. What all the model providers actually do. We are more on the right side, and this is the task side. So we can now use this already pre-trained model, and we can do different tasks out of the box straight away. So we might be able to do information extraction, instruction following, object recognition, question answering, also coding stuff. So we can do pretty many things just by using this already pre-trained foundation model. So this is foundation models and large language models. And now the world is talking about agents all the time. So what are agents? In a really basic setting, an agent is just an entity who can act with its environment. So for example, it can do specific actions and then act on its environment. And those actions actually change the state of the environment, right? And also maybe the agent can, also maybe the agent can then observe the state of the environment. So its action change what the environment actually is the status, and then the agent can observe what the impact of its own actions are. And how comes this all together with large language models? So what we now can do, we can say, okay, our agent is the large language model plus tools that we provide. And this works because large language models actually can do some sort of planning, and if they have some tools, they also can do actions. A typical action could, for example, be, I want my agent to read a database, or also to write a database, or to read an email. So this could be a typical action that we provide to our agent. And then the state where the agent actually, or the environment where the agent actually acts on, could be your computer. So your computer, once the agent has done a database entry, it changes the state of your computer. So this could be the environment the agent lives in. So this is all about agents, and on a very basic level, I would say. So how do we now go on, and what is important to use these agent frameworks and also language models? So we need to do, in my opinion, at least two things. The first thing is we need to define the tools, and we need to define the control level the agent actually has. So we want to provide tools that the agent can read data, that it can write data, that it can do meaningful actions on its environment. And this is especially interesting in the context of manufacturing, or for example, with using real-time data. This is the one thing. And the second thing is that we need to provide this context, which I mentioned earlier. So we need to make sure that the domain we are putting our agent in is quite understandable for the agent. So it needs to know what the data is about, what the relations are. And what we typically want is to reduce ambiguity. We do not want to interpret the agent some things that we haven't defined. We want to have clear instructions. We don't want to have any things the agent just does because it has seen it somewhere else. So we want to reduce this ambiguity and help to make better decisions. So, and this is where the unified namespace might come in.
Oh, sorry, you already skipped. All right. So essentially, the AI agent has to solve the same problems as John in the beginning. He needs to get access to the systems, and as long as you have the silos, this is quite difficult. So this is exactly where Unified Namespace comes in and provides real value also for building AI agents. So the Unified Namespace helps us to break up those silos. So instead of going to each individual systems, all the systems on your shop floor publish their data, their state, their events into the Unified Namespace, no matter if it's machines, if it's a SCADA system, the MES, ERP, AGVs, even the forklifts, they all publish their events and state into the Unified Namespace. So it's becoming this single source of truth for the current state of your factory or all of your factories even. And so the Unified Namespace can give access to this current state and the real-time data. And what we also always do in all of our projects is that we more or less generically persist all of that data that goes through the Unified Namespace into both the time series database and into object storage for example, for using it for machine learning trainings or giving access to data analytics tools like Azure Fabric or similar. And we built these persist services in a way that they can just generically persist everything that's being published on Unified Namespace, and we can define which essentially data sets go exactly where. So you might have, your production orders in the object storage, and you have the machine data, and you have, lots of small data sets with cleaned, well-structured data that you can directly use for data analytics and similar things, or for having an AI agent access them. So now we have not just the real-time data, but we also have the same data stored, all the historic data in both a time series database and in object storage. So now we can give AI agent access both to the real-time data as well as the historic data. It happens to also, the Unified Namespace also helps with giving the second problem, with the second problem. So Unified Namespace gives the data context. So of course, the messages themselves, the content is context for the LLM, but also the structure of the Unified Namespace itself. So the structure of the UNS gives the messages, the data that's being published, events that are being published, additional context. So for example, if you have some KPIs like availability or OEE that are being published for this paper machine, the language model can determine, okay, this is this has a relation to the paper machine 1 in the paper production area in the plant in Frankfurt in my paper company. So it can get context from that, but it also can get context from the data that we're publishing there. So this is an example from some scale that is measuring the weight of the mother roll in the end of a paper production process. So this has also additional context, like it has the location, what type of machine it is, it has a name, it even has a lot number for the current mother roll, etc. So it can have a lot of additional context from which the LLM can draw relations between data and help it better understand the data. So now it might be able to tell, okay, this is a machine if you ask for it, or this is a scale, and it can discover that data. And do you think we have time for the big architecture picture?
Yeah, if we keep it. Yeah.
Then we do one additional slide. Just to give you an idea how an overall architecture of such a UNS-based platform that we built looks like. And I picked an example on purpose that does not only include -Q, but also Cybers, CONNACK, because the colleagues are here today. So this is a project for process industry. We typically have an environment either in the cloud, a central environment, or in the corporate network, and one environment per plant based on Kubernetes. And if we go from left to right, so we have some connectors connecting to PLCs, sensors, maybe some systems on the shop floor, getting data from there, standardized, transforming, normalizing, standardizing data. Then they publish it in a MQTT broker in the plant local unified namespace. So you have all the real-time data for this plant in this MQTT broker. And then we bridge that broker to the global unified namespace broker, which is often located, for example, in this example on Azure. And then we might have services there consuming that data or publishing data, sending something back, maybe even to a machine. And we then forward the data into Confluent Cloud, this is Kafka, and have then the two generic persist services that write the data to a timescale database and to Azure OneLake. So this is essentially how the overall architecture looks like, and how the data ends up in these data stores. So as soon as we publish something in the unified namespace, it will automatically also be persisted in both data stores. And now we're going to zoom in on the cloud side. So where we have the service, this would there would be the AI agent be deployed, and Kirill is gonna go a bit more into detail on how this looks like on an architecture level.
Yeah. So where does it all start? So maybe we have some agentic framework which we use. This could be something like a LangGraph, for example, and this mainly is the component responsible for doing the agent stuff. Then we might have some sort of gateway which makes sense in order to monitor what actually goes in and what goes out. And now what we do, and this is the thing that you might have heard of, this is this MCP protocol, which is becoming really popular these days. So what you do is, on the left side you have the agent component, on the right side you have the tools that the agent now can use. And these tools are provided via MCP, which is a new protocol that came up in last year. It stands for Model Context Protocol. And if you ask me what is special about it, there is nothing really special about it. It's just that there is a protocol now that standardizes the agent tool interaction. And what it is, it's really a simple protocol that allows the agent to call remote procedures. So it's based upon a JSON RPC, and this is mainly it. But it allows us to really flexibly bring up new tools. So we can spin up these new tools, and the agent really can read, what is this tool about? Because this tool is self-explaining. And the agent now can decide, okay, I need this tool in order to do this job. And the agent can do its reasoning and planning on its own, and can decide which tools to use at which time point. So this is the one thing. And then also, there maybe this is an Azure-based reference architecture. So here we might use Azure Foundry in order to use our LLM models. And what we also could connect here is, for example, something like a blob storage, where we might have some searchable index in order to do retrieval augmented generation. Or for example, we want to retrieve information from our unstructured data that we have. So this is such a typical RAG flow that there is also integrated. Okay, so this is the architecture view, and now let's bring it all together in a really concrete example. Here I forgot maybe to say that this LLM gateway also allows you to connect to other models. So you could, for example, use Anthropic or Mistral or Google Gemini, all those models via this gateway.
An example for the files that you might want to include there via SharePoint or whatever would be like maintenance documentations, things like that an AI agent might want to use as well.
Yeah. So what we typically see is that there's a lot of documentation that typically needs to be searched through, and this is something that really works well. So let's bring it all together in a really concrete example. We have something brought up here. This is the pizza factory, which you can see in this image depicted. at least in an abstracted way. So what we have here, we have different lines and areas. So we have the dough preparation area, we have this portioning and forming area, freezing, packaging, everything that is needed. And we want to now consider this case. So here is John again on the left side, and John now has different questions. Like, for example, I want to compare my machines in the dough prep area based on their running time. What was the ambient temperature of the last 10 days in my freezer? And what was dough temperature and ambient temperature in my netting machine X? So these are some typical cases where John might need some data engineer and also some data scientist in order to write those queries and to bring up the data. And now we can do these things with an agent in place and bridge the gap between John on the one side, the data on the other side. And we use the LLM to transform John's questions into some structured query. And then the agent can decide which data actually to retrieve. So how this could look like, something as this. So here we have this little chat UI. So here John asks, give me the ambient temperature and humidity over the last 7 days, I guess. And then the agent decides to query the historical data. And of course, the agent also knows how to visualize this. And so this is something which might be helpful as a spot service. And also here's another example where John now compares the different netting machines with such a Pareto plot in order just to do some quick analysis here. So these are really some spot-on things for data analysis. And now we wanted to dive into another example, which actually is a bit more, has more steps. So it leverages information that we built during our conversation with the agent. And this is here in the following video. So again, I'm in my demonstrator, and now I have this unified namespace access. And what you see now is we go to a flow and we query different data, different time points. So now first, what I do is I ask the system what actually is being monitored and what systems the agent can access. So I have also brought up here some quick actions. Maybe you have some prompts that you typically want to use. So here I ask what systems can you subscribe to. Now here I have two areas which the agent can monitor. So there's this baking area and the freezing area. And you see all the topics and attributes that these areas have. So this is what the agent's domain. So I deliberately restrained I didn't give the whole factory, but I restrained it now for two areas. So now you see in the freezing area we have this alarms topic to see whether there have been any alarms recently. And now I want to subscribe to this alarm topic, and I can ask the agent to do that. So here I subscribe, and now you see the agent now has used the tool to subscribe to the unified namespace. I can confirm this, that it actually worked, and because I have the response message from the tool. And now I can, for example, ask the agent if there have been any updates or any recent alarms. So this again brings me the agent again uses a different tool, and I find this temperature deviation alarm, which here is indicated as being cleared, but I still want to further investigate what's the reason behind it. So what I do is, this is from the freezing area, and now I'm asking my agent to actually bring up the data from the freezing machine, the last entries, so that I can get a clearer picture. And now the agent uses the DB tool, and it spins up all the data here in this database, which might be informative, but I still want to visualize this maybe to see if there has anything happened during this time period. So I ask the agent to to give me a nice visualization of this. So, and this is just what happens in the background, and you will see that now we will hopefully get this plot. So here is the cooling rate over the time, and you see there is a sharp decrease. So this might be the reason for our alarm that we have observed. So now first it were at 2.4 roughly, and now it dropped at one point during May 27th and May 28th. And this is, of course, an anomaly we should further investigate. So what I can do now, I can ask the agent again to search into the log files and see if there have been any changes in my freezing machine recently. So I'm doing this. And now the agent searches through the database records for the logging, and there everything seems to be fine. There's only okay, no anomalies detected. But here again is our temperature deviation alert. But this is the alert that we already observed earlier. So there is no explanation for this decrease in the cooling rate. So how do we proceed? So now we might leverage a different capability of our agent. We want to find dependencies. So maybe there is some other system which is responsible for the actual error. And now I ask the agent, are there any dependencies between these systems? And the agent now sees, okay, there's the baking area and the cooling area, and the baking area depends on the cooling and vice versa. And of course, now we only have those two systems, but you could build those relations in, for example, a graph structure, and the agent can then search through it. So now we find, okay, if there is some relation between baking and cooling, then we should also search through the baking and see if there has anything happened in this time period. And so I asked the agent, please also give me the center oven temperature, so that the temperature in my oven over time, so that I can compare if there have any if there are any correlations. And the agent, of course, does this again, and I now can see the oven temperature above, and below there is the freezing rate or the cooling rate. So the oven temperature seems to be in a normal scale. It's between 2020 something and 2026. So there's no at first glance, no correlation between those plots. So what I then do is I still think maybe there could be something in the heating. So I would also want to search the log files for the oven and see if there have been any changes. And now what we find, or the agent finds, is that at May 27th at 7 p.m., the thermostat has been replaced in my oven. And this is from a new manufacturer, which ensures higher precision. So this is really something we should be further investigate. So if the thermostat has been replaced, and this is exactly the point where the freezing rate dropped, so maybe this might be correlated. Of course, someone now should really check the thermostat if it reports the right temperature for the oven. So maybe it reports too high temperature, which then, or too low temperature, which then causes the oven to overheat. And then the cooling area does not work as efficiently anymore. So now what we want to do is I want to write a summary, what I found, and send this to the persons who can check the thermostat if it works as expected. Yeah, so this is some specific use case for finding root causes and finding correlations between different areas in your factory. And we find that of course this is a reduced setting here which we considered, but still it's impressive how the agent, when provided with the right data, is able to draw conclusions and help me quickly identify potential issues in my system. So now what you might think is, okay, yet another chatbot. Yes, in this case the UI is a chatbot and you might be needing prompting, but still there are other use cases and also other user interfaces and user experiences or other users that you might address with other solutions as well, but still have in the core an agent. So what we see is, and something really interesting is writing documentation automated. So for example, to comply with highly regulated domains, where each step within might need a documentation step, and also for doing at least automated reviews where the user then can quickly see and overview, okay, this review is all right or not, but it does not need to write it himself. Another use case might be alarm rationalization. So machines might output alarms which are cryptical or hard to read. And it might add it with additional context information so that you can better understand what the alarm is actually about. Then the use case which we call the pocket data scientist, which goes into the direction that we just showcased you. So really being able to do data science stuff with your agent. Breaking language barriers is something really interesting because, there are factory sites around the world maybe and different users and different languages. So you might be able to better translate stuff. And also, when you think about the other point that I mentioned, so in order to use large language models, you might be first building this context. And this is something really intense maybe, but you also can leverage language models in order to build up this context. So it turns out that models are good at transcribing spoken language, for example. So we might be able to just speak it into something, and the LLM is then transcribing it. So these are some of the use cases, but where is it all going? I will give over to Marc.
So what's next? What do we have to look into next? So one thing I think we still need to get a better understanding and feeling is what should we model explicitly that we expose, like APIs that we expose to the AI agents. For example, HiByte allows you to define APIs and then expose those via MCP so they can be used via an AI agent. But you're modeling the APIs explicitly, so it's still programming essentially, even if it's a low-code interface, but still. And you explicitly define those. Maybe we would do that for if you let the AI agent make changes to your production because you want to have some safeguards in it, things like this. And how much can we leave up to LLM magic? Like, of course, this allows us to be more efficient because we have to define this explicitly. And I think still have to figure out like where's the sweet spot between these two things and when to use what. I think this is for us still where we need a better understanding, I think. And then the second thing is to still better find even better ways to give more context to learn how, like, what do we need to include as metadata into our messages? What do we need maybe to publish as metadata, as retained messages on certain topics? Like, what does help the LLM to do things better by itself without having to define things explicitly? So I think this will stay a learning journey, and you will just over time also add metadata to your data to improve this. And then the third thing is the enterprisey thing. So in the end, can think of the AI agent also as an API. So you have to do all the things you need to do for an API. You have to deal with authentication, with authorization down to row level or field level authorization, maybe PII filtering, all these things, you know, from other APIs, and how these work together, for example, with MCP, which haven't been thought of when designing the protocol necessarily. So those are also things where we still have to find the best ways how to do this with MCP servers, and how to really include. So, for example, the authorization works with the permissions that the user has and not that the AI agent has, and how do you pass it through the whole chain of, you've seen the whole architecture, so there are a couple of steps, and how you do this properly, so you're actually filtering the data based on the permissions that the user has, that the AI agent uses. So these are still things we have to work on, but that are important for any manufacturing context for sure. And yeah, so we have a plan for some time for discussion now, but also yeah, let's start a discussion today and talk about these topics. And we still have some 8 minutes for questions now.
In the beginning, you said that you are writing the data from QDT to a time series database and also to a data lake.
Yeah, essentially, yeah.
The same data.
We. Okay. Yeah, we do write the same data. We just often don't keep all the historic data in the time series database, or not for eternity, but maybe just for the last 30 months or so, because we use the time series database more for operational things like dashboarding on the shop floor, and they might want to compare last month with the month the year before, but they don't want to go further back in history. Like we've done some logging on what people are filtering for, and the experience is, it's maybe in the year it's twice more than 13 months or so. So it's not necessarily worth keeping it for eternity in the time series database. And we also put it in the object store, because then you can, for example, use Azure ML to do machine learning trainings directly on the data you have stored there, or use something like Azure Fabric, since we're on the Azure example. But the same applies to AWS and Google Cloud, of course. They have their own respective tools. And that's just where the object store is a better fit.
Thanks.
Very nice example, thank you. In your example, you showed that you asked for interdependence between areas. Is that something we need to go into, like the APIs and the context, or is it something the LLM was actually capable of understanding?
So in this case, the LLM in the end was really capable of understanding those dependencies. I would say if it's getting large, then it might make sense to explicitly model those relations between systems. And there is something like really knowledge graphs, for example, which might be useful for those things. This can be done also again by leveraging LLMs in order to do the heavy lifting of all the relations in the complex system itself. But yeah, I would say at some point maybe we might be better off by providing these relationships in the first hand, and not actually trusting the LLM to identify all those relationships by itself.
For the LLM gateway, are there any tools that you have experience with, processing tools?
Yeah, what we typically use is something like Light LLM, which really allows you to, for example, define teams and also organizations, and you can provide teams with different API keys and do really like access control, which team has access to which resources and to which models. And also at the same time, you can do really good monitoring and see how is the traffic, how is my usage, how are the costs. So this is something that works pretty well. And also it provides you at the same time like a standardized interface for all your models. So if you query GPT models on Azure, or you query Gemini, you have one gateway which standardizes all the different APIs.
That's one interface for all the models.
Yeah. There's a question here.
Thank you. Very nice presentation. Just a thought that I was considering while watching this. I could see
for example, correlations. It's a mathematical term. It's not something that is just like, it's something based in mathematics.
Mm-hmm.
And so in general, we have big problems in companies, I think, with not making sure that users have data that they can work with, things like this. But I could also see a situation where like management, then different part of the organization would come up with like thoughts and questions that are based on things that they would receive from LLM like this. Like, oh, we've seen that there is a correlation between this and this, so now go and build this. And we could end up in a situation where I have to constantly check. Well, this assumption that they have made, is it actually, I guess it comes back to a bit, you just answered partly my question in the sense that you should start build those things into the metadata that we have actually validated that there are correlations already. But have you like considered this?
We have not strategically considered this at the point we are now, but you're absolutely right. So this might bring up some new issues, and also, let's say, for example, if the LLM does some hallucination, it hallucinates some dependencies which aren't actually there, and someone goes and starts doing actionable things on this insight. This might be an issue at the time being, and I think there are two things which work against those things. The first thing is that model providers actually really work on reducing hallucinations and really bring the models towards, hey, you do not hallucinate things, you try to be factual, and you try to use the context that you have. And on the other hand, we are really, I think it's our responsibility to bring up the context that helps also to reduce these things. So if we have the knowledge and we know the dependencies, we might be better off by explicitly modeling those. And I see an LLM as something which connects things, but I wouldn't want it to fantasize or bring up new stuff, at least for those domains. So it's more connecting the dots for me.
And also the AI agent might use regular machine learning models as tools to discover correlations or to discover anomalies in the data, and use classic machine learning as well.
That's a good point. You really can ground those assumptions in, for example, machine learning models. So you say here, this is the data one. Please ground this with some specific, explicit machine learning model that you use.
Thank you.
There is one question.
And these chat thingies are nice if you are debugging errors in the shop floor, but what do you think, how deep can these kind of agents go in influencing the shop floor, like adjusting speeds of the machine and all these kind of things? Do you have some kind of experience already in that?
To give you an example, like this might not even be visible to end users that there's like AI in the background, but think about an operator terminal. The operator gets this error that Kirill talked about, and then he gets an explanation for it and a suggestion how to resolve it without having to talk to maintenance, for example. And it's just integrated in the operator terminal, and it's not even transparent that, you know, where this is coming from. It just feels, okay, this is the explanation for the error code, and this is how it was solved the last 5 times by maintenance. I don't know, things like this. So you would integrate it into the applications and tools that the people on the shop floor use, and not necessarily use a chat interface anymore.
Okay, but more as a suggestion for the operator, not automatically within the machine itself.
I would always go for that it suggests you something and then maybe offers to execute to resolve it, but never to currently not to automatically do something, but more like suggest it, and then, you know, an operator or whoever can confirm that it's the right step to take. For example, change the setting of a machine or something to resolve a problem, but it would always be in the responsibility of a person to decide if this is the right action to take.
All right. Then please come talk to us in the breaks. I think this is a really interesting topic, has a lot of potential also on how to integrate this. That was a very good final question, how to integrate this into existing applications and create value for the users. Thank you.